SAMRI is more than just another building on the Adelaide skyline. Within its laboratory walls, the work undertaking is innovative, groundbreaking and potentially life-changing. But to achieve this completed outcome required some heavy lifting from both the design and construct teams. In this edition of NDY TV, we'll delve into the engineering design elements which have contributed to the success of this remarkable research facility.
SAMRI is not just a building. It is a building with a function. SAMRI was built with the intention to attract international researchers, so everything was thoroughly designed around a vision of collaboration.
The project was a new research facility for Adelaide and was intended to be an iconic research facility, something that the South Australian people could be proud of and could talk about, but more importantly something that would attract the interest of overseas researchers and become a magnet for the best possible people.
It really allowed us to challenge the typologies of lab design to try and create a new and improved environment for researchers to work in.
A diagram to illustrate that is, you have the convention. We were given here the opportunity to break the convention, so taking the convention and spinning it on its head and looking at other ways of how we can influence and promote collaboration.
NDY were involved in the initial concept design of the building, working with the architect to develop the spatial requirements, and from those spatial requirements we then built the detail of the systems around that to produce an integrated building with all the services required for a high-end laboratory facility.
Part of the issue of a laboratory like this is translational research, and that is converting the research into meaningful drug discoveries that can then be applied to treating people in a clinical sense. The space had to be designed so that it facilitated people interacting in a normal sort of way.
Void spaces and interconnecting stairs and bridges provide a sense of openness and reinforce the importance of the building being a shared, almost communal space.
Now, conventionally also the lab component sits along the perimeter of the building. We actually put it internally and allow that open up into the workplace. Big void spaces, interconnecting stairs, bridges that gave the ability to people when they passed that actually bump into each other and exchange a conversation. So all these components adding to almost like a vertical and horizontal village where there's a huge energy of collaboration.
Cyclotron, it was an interesting exercise in that we knew there was a cyclotron going in the building, we just didn't know what form that would take. The cyclotron was located in the basement of the building. We needed to provide spatial allowances for the various exhausts and services to run from that basement all the way to the roof. To get that installed or designed after the building, the construction had commenced and after the design had been completed was quite a challenge in itself.
Achieving the design outcomes for an unconventional building shape and one with quite strict laboratory requirements meant that building information modelling became an important conduit to coordination amongst the design team.
We promoted the use of BIM on this particular project. It was about developing a 3D model and having all of the consultants integrated into that model. So architecture, structure, services, all integrated into that single model, and that model being used as the design tool to verify that systems can be installed without clashes of beams and so forth with ducts, etc. NDY took the lead and were the BIM facilitator on that job.
The software that we used is one that works with the subcontractors as well, with the builders. So this exchange was occurring on a number of levels, not just within us as a team, but the broader team of the people who are going to be involved in building it.
In terms of the value of the BIM, I think we used it very usefully to help our client visualise what it was we were offering them, and specifically to actually demonstrate the construction sequence for the contractor once they'd come on board to test a few options. That was an incredibly powerful capability to actually demonstrate how the building would go together.
And I think in the end we probably wouldn't have been able to get the level of coordination in the building without a whole lot of variations and issues that occur on site if we hadn't done it using a BIM 3D model.
The outside skin of SAMRI is one of its defining features. Its mesh-like qualities act as a metaphor for the interconnectedness that this building encourages amongst the building's occupants. And it's that facade which is contributing to daylight optimisation, energy savings and ESD credentials of the building.
The conceptual idea behind the facade was looking at how nature behaves. For example, we looked at the idea of the pine cone, how it adapts to its environment. And we thought, well, how could this building, through a repetitive system around it, also behave in a way where it responds to both its orientation and also to the functions that occur internally. That's come about through these sun hoods, which become quite expressive, and they move out in various distances. Just like the pine cone, its petals move in and out, these sunshades, they move out in various distances and provide different levels of shading, optimising daylight, reducing glare and maximising comfort internally.
Making the facade perform to its best possible level of performance takes the strain off a little bit off the engineering services systems, so particularly the air conditioning systems. It enables us to get those systems operating more efficiently and then achieving a sustainability rating that is quite high for a laboratory facility like this.
We used an innovative solution that we'd applied to a project in the UK, which basically involved creating a double skin construction on the western side and created an accessible space which allowed us to bring in services down the track in the future without impacting on the operating spaces. In other words, the laboratories above the lab we were modifying. You could add a fume cupboard or an exhaust system quite easily by bringing it down the outside of the building in this interstitial space and then popping through into the laboratory space.
With the type of research that's being undertaken within the laboratory space, it requires full fresh air to be introduced into the space, which then gets exhausted, and through that exhausting you lose energy, which we've introduced systems that actually capture that energy as it's leaving the building and then reintroduce it into the supply air stream.
The building services and systems at SAMRI are highly integrated. These allow the building's design, layout, infrastructure and connection to the ground plane to orchestrate as one.
At its completion, this is going to be the first institute in the world that's going to have that level of integration of systems within a building.
By integrating all of the engineering services systems within the building over a common communications platform, we're able to optimise the energy efficiency within the building to a very high standard.
On such a complex project like SAMRI, teamwork has been paramount right through the early concept stages. Through our contribution with constructability, it's been paramount for us to work as a group, both within my team and within the design and consultant group, ensuring we've got the right outcomes for SAMRI and the project as a whole.
A lot of the information that we've produced have had to be then fed into the US Green Building Council. They came back with a whole lot of questions and so forth that we needed to massage and rework or remodel and validate the requirements of the LEED rating tool. We've got to a point now that we're at comfortable gold rating, and that's a great outcome for a facility like this. So achieving that gold, and it looks like we're going to get gold right through to the construction phase. So not just design, it'll be construction as well, so it'll be a great outcome.
SAMRI nestles comfortably into its environment. It doesn't try to dominate the surrounding parklands, but rather its form appears to float above the ground, allowing the public to walk directly beneath the building. This human interaction is an important design element which is deliberately sought to embrace the local community.
We took this idea that what about if the building floated above the parklands and it was given back to the public below it?
The idea there was that although the building is 3 levels below ground, essentially, to get that floating nature, it almost had no area where you could run your services. It sits on the flower columns, and the flower columns try and minimise the impact of that ground level. So our challenge was, how do we get our services out of the bottom, which is highly serviced, our main plant's down there as well, up to level 3 and beyond to level 9. If it wasn't for using 3D modelling, it would have been quite difficult to achieve.
SAMRI's fluid form is not just breathtaking design, but carefully crafted to eliminate work silos and foster collaborative outcomes.
Its uniqueness was that space was created basically for the public to attract people into a medical research institute where we can teach our community how to live healthier.
The brief has been responded to very, very well. It's ticked all the boxes. We've managed to meet all the design requirements, the functional requirements.
Excited to see such an avant-garde, bold statement.
From NDY's point of view, we're certainly proud to be involved in this particular project. It's a landmark project.
Its design, its functions now are going to deliver exactly what we hoped for, attracting the international researchers and creating that space of creativity and uniqueness for medical research. We are fulfilling the vision that a few years ago was just a dream.
It's a project that has had enormous challenges, but it's the sort of project that every consultant would love to have on their CV, and we're very proud to have SAHMRI on our list of completed projects.
For the City of Adelaide, SAHMRI represents a vision of leading technology and design. But perhaps more profoundly, SAHMRI stands as a symbol of a modern city with a clear line of sight on attracting the very best talent.